So yeah, so actually we were discussing about these questions yesterday. So see, so we need to find the value of I of t. Okay, so for this your initial switch was connected, like how's the initial switch will be connected? The video is recording. So how's the initial switch will be connected? Before means at t is equals to 0, switch is coming down. So before coming down, my figure would be like this: 60 volt. This particular is your 31. This particular is your 31, and this is your inductor. Okay. Before t is less than 0, the switch will be like this: 30, 30, 10. What will happen with this inductor? What will happen with this inductor? We need to find the value of I of 0 minus. Means from infinity, from minus infinity to, it was like from minus infinity to at time 0, the switch was steady state. So this omega value, if you will put 0, it will become short circuit. So what will be the current? Current will flow in this particular. So this is 60 volt, this is also 60 volt, this is also 60 volt. So what will the current will come? I will come 60 by 10. So I of 0 minus, we are getting 6 ampere. Okay. So we know the value of I of 0 minus. What about I means this I of 0 minus, and we know the inductor current I of 0 minus is equals to I of 0 plus is equals to I of 0. This is I of 0. So this value is coming how much? It's coming 6 ampere. This particular value, it's coming 6 ampere. Okay, fine. If it is coming 6 ampere, now if you will get the circuit, now your circuit is becoming like this. At t is greater than 0, your circuit is becoming like this: 10, this is 30, you have a inductor is coming. Okay, this particular inductor is coming, and this is plus minus 60 volt. The circuit is becoming like this. So this is 30, this particular is 30. Now you need to find the value of I of infinite. So at infinite amount of time, what will happen with this particular inductor? It will become short circuit. So 30, 10, 30, and this is short circuited, and this particular is positive negative 60 volt. You need to find the value of this particular current. Okay, this particular current you need to find. So how you will find this particular current? So these two are parallel. So 30 into 10 divided by 40. So how much you will get? 30 by 4. And if I am getting a short circuit wire and a resistor coming a parallel across this will become redundant. So my circuit will be like this: 30 by 4 short circuit, and I am getting positive negative 60. So what current I will get? I of infinite will be 60 divided by 30 by 4, so 4 will come. So I of infinite I am getting 8 ampere. Okay, if I am getting I of infinite as a 8 ampere, so what is the meaning? 8 ampere current is going 8 ampere current is going from here. This combined is 30 by 4, and that 8 ampere current is traveling from here. There will be a 0 ampere current because it's short circuit path. Okay, so now you need to find the value of I of t. So I of t will be I infinite minus I of 0 e power minus t by tau. So first you need to find the R equivalent. So for finding the R equivalent, what we have to see, this is my circuit, this is my 10 ohm, and this is 30 ohm, and this was the inductor. So you have to see from here. Okay, and one thing, the sources will get short circuited. So what will the R equivalent will come? If you are taking this point as a point, this is A point, this is B point, this is B point. So from, and this is your A point. So in between A to B, so you need to find, so A to B, what is the connections? A to B I have a connections of 30 ohm, A to B. Okay, and any other connection? A to B I have a connections of another 30 ohm.
One more 30.
Yeah, and any other connections? 110 ohm. So 110 ohm. So what is the value I am getting? This will become 15, this will become 10. So 15 into 10 divided by 25, right? So this is 3, this is 5, and this is 2. So I am getting 6 ohm. So substitute the value this in this equation, in this particular equations. If you substitute in this particular equation, what you will get? I of t is I of infinite I got 8 ampere minus 8 ampere, and I of 0 what I got? I of 0 I got 30 by 4, 30 by 4 e power minus t by tau. So e power minus r equivalent, how much you got? 6, and L is given, the value of L is 1 by 2. So RT by L, so 2 will go upside only. So you are getting I of t value is 8 minus 32 minus 30 by 4. So what value you will get? 8 by 32, 32 minus 30 into e power minus 12t, right? 8 minus 32 by 4 is 32 by 4 is 2, 1 by 2, 1 by 2 is 0.5, 0.5 e power minus 12t. So this value you will get. So same answer you got or different answer?
Same answer, sir.
Same answer, you got the same answer. That's fine then.
Yeah, same.
You understood means how to solve these questions. That's mean.
Yes, sir.
Okay, fine. So this was the basics, just a simple basic question. Okay. So guys, we solved this particular question. Eight minus, yeah, see what I want to say you. I value, I value will get, okay, okay, just wait for a minute.
Six, sir.
6 will come, no? Right?
Yes, sir. Yes, sir.
I value. So, yes, I of infinite will come 6 ampere, I think. So, 6. How Priyanka 6 will come? 60 is there, 60 divided by, oh,
I of 0 is 6, sir.
I of 0,
I of 0.
I of 0 value will come 6. Oh, just wait. Yeah, yeah, yeah. I of 0 was 6. It's okay, fine. So, so this was 6. Right, I of 0 was 6. Okay. So if I of 0 was 6, as a substitute, so 8 minus 6 will be 2. Rest all the things are right on the minus 6. It's 2. Okay. So I of 0 value, we got 6. Huh? Yeah, the answer is correct only. So 8 minus 2 e power minus 12t. Right?
Yes, sir.
So, okay. Now you have a different questions. Means like suppose you have a question. This is your particular question. So in this particular question, you have a 3 kilo ohm, that is positive negative 24 volt. This is 5 kilo ohm, and initially the switch was like this. Okay, this is 0.5 microfarad, and the switch is moving from position 1 to position 2. This is 4 kilo ohm. This is positive negative 30 volt. 30 volt. So in this question, what you need to find the value of a v of t for t greater than 0. For t greater than 0, you need to find the value of v of t for t greater than 0. Okay, so if you will see the circuit for t less than 0, our circuit will be look like this: 24 volt, 3 kilo ohm, 5 kilo ohm, and that is your capacitor. So what will happen with capacitor? It will be open circuited, right? It will get open circuit. So if it will get open circuit, this is 1 by j omega c, and we are putting the omega value is 0, so it's getting open circuit. So this is my 5 kilo ohm, this is my 3 kilo ohm, and here capacitor is connected, that is I am representing as a open, and that voltage I need to find, and this is positive negative 24 volt. So you need to find the value of this particular branch voltage. So V will be how much? 24 into 5 divided by 8, 5 plus 3, so you are getting 15 volt. So this VC 0 minus is equals to 15, and we know the condition for capacitor, VC 0 minus is equals to VC 0 plus is equals to VC of 0. This thing's done. Now when the switch will move from for t greater than 0, how will be the circuit? This switch is moving from one position to this position, so we are getting a capacitor like this. This is one resistor, and this I am getting one source 30, okay, and this is 4 kilo ohm. This particular is your 4 kilo ohm, and this I had assumed the directions of the voltage is in this VC, and this is your 30. So in these questions, what will be the VC of infinite? VC of infinite, it will again get open circuit. So if it will get open circuit at infinite position, I am having a positive negative 30, and the current will be 0, so here the voltage drop will be 0, and the same voltage will come across this 30. So VC infinite we are getting how much? Minus 30 plus VC is equals to 0, so VC value we are getting 30, so VC infinite value we are getting 30, right? So now you need to find the value of R. So for finding the R value, we have to see for t greater than 0. My circuit is how is looking my circuit for t is greater than 0. It's simple. This particular and this positive negative 30. So for finding the value of R, you need to remove this, and you have to watch it from here, and this will become short circuit because it's a voltage source. So you are getting 4 kilo ohm, means R equivalent is 4 kilo ohm. So VC of t will be, VC of infinite is 30 minus VC of infinite is 30 minus VC0. VC0 was 15 minus 15 e power minus t by RC. R we got 4 kilo ohm into capacitor we have 0.5 microfarad, 0.5 millifarad. It's not microfarad, it's millifarad. So this milli and this k will get cancelled out. So we are getting 30 minus 15 e power minus t divided by, it is 10, it's 2, it's 1, it's 2, so it's 0.1 by 2 is 0.5, it's coming. So 30 minus 15 e power minus 0.5 t, e power minus 0.5 t. So this will be the value of the voltage. Understood, Priyanka?
Yes, sir.
So VC of t value we are getting this. So this is the case. This was the case of the the main things we completed. Now we are moving for a special cases. Special cases. Write it down, the special case. This is our special case. So write the first question of the special case. There is a one question. So question is like n below given circuit or network at t is equals to 0 second, a switch is connected at position 1. A switch is connected at position 1, and after one time constant, see the parameter time constant, it's given one time constant, it is moved to position 2. You need to find the current response I of t when the switch is connected at position 2. See, so diagram is like this. This is my figure. This particular is my positive negative 100, and this is my positive negative 50 volt, and this is 1 ohm, this is 100. So position 1 is this one and position 2 is this one. So guys, see, it is given at t is equals to 0, a switch is connected at position 1, means it is connected at position 1 at t is equals to 0. In a below given circuit network at t is equals to 0, switch is connected at position 1. Okay, we are assuming. So this is the case of a two circuit. Okay, you forget about this parameter. You first forget about this parameter. Now think like this. You have a circuit like this particular circuit. You just think like this. You have a circuit like this only. So earlier it was not connected. Before t less than 0, the switch was not connected. So that means I of 0 minus is equals to I of 0 plus is equals to I of 0 is equals to 0 ampere. When we'll connect this switch, this will become like this. Yeah. When we'll connect this switch, this will become like this. This particular circuit will become like this. Now what I am saying, now for t greater than 0, this circuit is for t greater than 0. So this will become short circuit. This will become short circuit. We need to find the current. We need to find the current. So we'll get one R value only, and that R value is 1 ohm, and this value is 100. So how much current will flow? 100 divided by 1. This is my I of infinite. So what the equation I will get? And while plotting the R equivalent, there is only one R. So R equivalent will be, if you will get the circuit like this, and if you will see from here, and this will become short circuit, so you will get R equivalent as a 1 ohm only, right? I'm not talking about this particular circuit. I'm talking about only this circuit, this small circuit, position 1 circuit. So I of infinite I am getting as 100. Now what is my I of t? I of t is 100 minus 100 minus 0 e power minus RT by L. So I got the current equations of 100 into 1 minus e power minus R value is 1. So e power minus, and L value is 1. So e power minus t. So this is the current equation I am getting for this circuit. Okay. Now what they had said, in a below given figure, the circuit network at t is equal to 0, a switch is connected at position 1. After one time constant, it is moved to position 2. Means after 1 second, it is moving to position 2. Okay. So, but we got the circuit, we got the current of this kind of a circuit. Now what they are saying now? They are saying after 1 second, my switch is moving. My first it was connected, and after 1 second my switch is moving to this position. So guys, I have the current equations of this. I of t is equals to 100 into 1 minus e power minus t. Put the value, t value as a 1. So I of 1 second will be equal to 100 into 1 minus e power minus 1. Okay. While you will calculate this value, you will get how much? 100 1 minus e to the power minus 1 into 100. How much you will get? 63.21. 63.21 ampere. I of 1 second. So this means what? I of 1, just like 0 minus, I of 1 minus will be equal to I of 1 plus will be equal to I of 1, because inductor does not allow the sudden change of current. So it's behaving like your 0 minus 0 plus 0. Now you are getting a new circuit, that is, it's connected to positive negative 50 volt, and you have a resistor that is 1 ohm only, and you have an inductor that is 1 Henry only. So I of infinite for this circuit will be how much? This will become short circuit. You will get 50. Now the final equations of I of t will come how much? I of t will be I of infinite minus I of, now you have to write 1 minus, because we are considering after 1 second this circuit. So I of 1 minus into e power minus RT by L. The R value will be 1 only, and the L value will be 1 only. So I of infinite, how much we got? 50 minus 50, and I of 1 minus is 63.21. E power minus t. So this is the I of t. I of t is 50. Now 50 minus 63. 50 minus 63.21, you are getting minus 13.21. So plus will come, plus 13.21 e power minus t. Okay. Now one thing I just want to this will be your t dash. Okay, here it will be a t dash. It won't be a t. It will be a t dash. Okay, and actually this t dash is occurring for, if you want to make in with respect to t, I of t will be 50 plus 13.21 e power minus t minus 1 you have to consider, because we have taken 1 second, so that's why the timing will be minus 1 second. Priyanka, not understood?
Yes, sir.
See, see, I will tell you once more. See, the thing is that assume what I am telling, what they had given. In the below given circuit network at t is equals to 0 second, a switch is connected to position 1. Means at t is equals to 0 second, they are connecting the switch at position 1. Right? At t is equals to 0 second,
Yes, sir.
switch is connected to position 1. And after one time constant, after 1 second, means after one time constant, again this switch is moving to position 2. Right?
Yes, sir.
Means they are doing a two switching. At t is equals to 0 second they are moving this,
Zero.
and after 1 second again they are moving to this point. Right? Right? So
Yes, sir.
before t is less than 0, how was my circuit? It should be like this only.
Sure.
Okay.
Yes,
And at t is equals to 0, how will my circuit? It will be like this.
sure.
Okay. And at t greater than 1 second, how will be my circuit? This is 100. This is 100. Now it is connected to 50, positive negative 50 supply. Right?
Yes, sir.
So we need to find for this value. Okay, we need to find for this value. So how can we find? First we'll solve the circuit one. So I don't know about this particular thing. Okay, I don't know anything about this particular thing. Okay, so what I am doing, I am considering only position 1. Right? I am considering only position 1. I am just forgetting this particular thing, and I am solving for this. So first I will find the value of I of t. So I of t value, how can I get the I of t value? I of 0 minus was 0. Right? I of 0 minus was
Yeah.
0. Okay, in this circuit, if it will be at t is equals to 0, so I am assuming, oh, my infinite circuit is like this. So I will get what current? 100 by
Zero.
1, 100. This will be the zero, this will be the zero inductor. Current will be 100 by 1. Current will be
100%.
100 by 1. So I of infinite current I am getting 100. So what is the equation? Please mute yourself, voice is coming. Okay, so what is the equation I am getting? I am getting,
Can you need to work for the super understand?
just wait. So I am getting this particular equation. Right? I am getting 100 by 1, and I of infinite is 100. Okay, so I of t is equals to 100 minus 0 e power minus rt by l. I got the circuit, I got the equation for this circuit. Okay, I got the equation for this circuit. So this current I got it. Okay, I of t is equals to 100 into 1 minus e power minus t. This is my current. Now what they are saying now, what they are saying, at t
After one
at t is
second.
equals to 1 second, my circuit is becoming different. right? At t is equals to 1 second, my circuit is becoming a little bit different. So after 1 second, what will happen? So that's why I have to put the value of a I of 1. So I will get 1 minus e power minus 1, that is 63.2. Okay, so this I of 1 now, this I of particular, this I of 1 is your, like you are getting, you are seeing now for 1 second later, right? You are seeing for 1 second later. So your original circuit equation was, how was the original circuit equation? I of t is equals to I of infinite minus I of infinite minus I of 0 second, this, and e power minus RT by L, RT by L. This is the original circuit. But now what we are considering, we are assuming our time is exceeded 1 second. Our time is exceeded 1 second. 1 second it's exceeded. So for making this, how can we write this? Means your t dash is what? Your t dash is actually, your t dash is t dash t dash. If you want to write the circuit like this, now the different time we are considering about different time. Let me tell you once more, means you will understand in a better way. Suppose this question is very difficult, but if you'll understand this concept now, so every questions will be easy for you afterwards. Okay, suppose you have a circuit like this. This is your circuit. This particular is 1 ohm. This is your 1 Henry, and they are saying this is your positive negative, and you are moving from minus infinite time to minus infinite time to infinite amount of time. Okay, so two kind of a transient is happening in this question. Two kind of a transient is happening, and there is a positive negative 100 volt, and this is your 50 volt. So first the position was this one, and the second position was this one. So before minus infinite to 0, my circuit was open circuit. Means minus infinite to 0, my circuit was look like this, positive negative. It was looking like this. So current will be 0 current because it was open. So I of 0 minus is equals to I of 0 plus is equals to 0 ampere. Now from 0 to 1 second, now you need to find the value at 1 second for getting the actual current. So what I am assuming now, I am finding not for 0 to 1 second, I am finding for 0 to infinite second. and I forget that at 1 second my switch is getting fluctuated. I forget that things, I don't know about that things, I forget it. So I will get the infinite I of infinite current. I forget, I am not connecting the switch at 1 second. Okay, I am not connecting the switch at 1 second. So in this particular circuit, you know na, at t is equals to 0 means in this is the current, this is the graph of your inductor, IL inductor. So the current was 0 0 0 0 0. The current was coming as a 0 0 0 0 0. So what it's happening now at this point, it's okay, it was 0. So I of 0 minus is equals to I of 0 plus is equals to 0. But at this is your 0 plus 0 plus. But what's happening, this particular switch was fluctuating to point 1 at t is equals to 0. If it will be connected to at t is equals to 1 second, I am not considering this, I forget that path. Okay, so what will be the current for the steady state? This will become short circuit, right? This will become short circuit. So how much current you will get? 100 ampere. I of infinite, if your new circuit will look like this, this is getting short circuited, and positive negative, it is 100. So what current you will get? I of L is equals to 100 divided by 1, so 100 ampere you will get. Means from 0 plus it was 0, but the current started increasing like this, and at infinite amount of time it's reached to which value? 100 ampere value. Okay, this graph you are understanding, Priyanka, what I am doing?
Yes, sir.
So this is 100 ampere current, but the story is different, you know. But the story is different. What is the story? At 1 second, this particular at 1 second na, the supply is getting changed. Means this is becoming your initial current, like I of 0 was. So it's becoming my initial current. So that's why I am writing now I of 1 minus, because inductor will not allow the sudden change of current. So at I of 1 minus is equals to I of 1 plus is equals to I of 1. Like here 0 minus is equals to 0 plus. It is becoming our initial value. Okay, or you assume a different case, you assume just a different case. Now it was for a time t. Okay, you can do like this also. You can assume a new case. What you can assume, like this is my 0 minus only, this is my 0 plus only, and this is my 0 only. I am assuming another circuit. Okay, means initial current it was given, that is what's happening here. Means you need to find the value of this particular current. So how can you find this particular current? Using the equation 1 only. I of t is equals to I of infinite minus I of infinite minus I of 0 e bar minus RT by L. So I of t I am getting 100 minus 100 e power minus t. So I of t I was getting 100 into 1 minus e power minus t. This is my current for first network. So I just want to know the value of this I1 minus. I want to know the value of I1 minus for the second operation of the circuit. So I am considering this as a I1. So I am getting 100 into 1 minus e power minus 1. So I am getting 63.2. So that is behaving, that is what, that it's behaving like our initial current. Now I have a circuit like this, some circuit which have a positive negative 50, and it's connected to resistor and inductor. So at infinite amount of time, how much current I will get? This is 1, this will become short circuit, so I of infinite I will get 50. Right? Right. But we are seeing this circuit, but we are watching this circuit after 1 second. Right? We are watching this circuit after 1 second. So my I of t equation will be what? It will be I of infinite plus I of 0 plus only, or you can write like this in my way, I of infinite plus I of infinite minus I of 0, 0 minus 0 plus whatever you want to write, e power minus RT by L. So this was the case for first equation. Now we are doing it for after 1 second. After 1 second, my circuit equation will be, for this equation will be, I of t will remain I of t, I of infinite will remain I of infinite, and I of infinite minus I of 0 plus e power minus R by L. So after 1 second, that's why we have to subtract 1 from this t minus 1. We have to write t minus 1. That's it. And now your 0 plus, if you do it now, so your 0 plus is like your 1 plus and 1 minus. Okay. So this 0 plus, it's denoting a new circuit. It is my I1 plus. And I infinite, I am getting this as a 50. So I am getting 50 plus 50 minus I of 0, I got 63.2. So this is my 63.2. Okay, this is my 63.2, and e power R value is 1 and L value is 1. So e power minus t minus 1, because the circuit is, this circuit is for 1 second delay. 1 second delay is there. That's why we substitute, we had substituted with time as a 1. So we are getting 50 plus, sorry, this will be minus now.
Formula, sir.
Yeah.
Always comes formula.
Yeah, it's minus. It's minus. So this is minus. This is minus. This is minus. So 50 plus 13.2 e power minus t minus 1 will get this particular equation. So what is happening? See the graph. It's not going, means up to 1 it's okay. We are receiving this particular thing. But at 1 second I am getting the value of a 63.2. Okay. But at t is equals to infinite, it's not going to 100. It's switching. Due to the switching operations, the price, the value got shifted. Right, the value got shifted. If you will put the t is equals to infinite, so it will become 0, and you will get the value, this value will get terminate like this. So it's becoming 50 at t is equals to infinite. Okay. Prasanna understood? Prasanna is not there. Priyanka, you understood?
Yes, sir.
It's clear?
Yeah.
So this is this is so what we are doing. I hope it's clear now. I'm justifying with you. 63.2. It's going like this, but the infinite value, it will not reach 200. This value, somewhere it's going like this, and it's getting fixed to 50. Okay, so this was the special case what we do. So you understood now why we do t that t minus 1, because for the 1 second delay.
After 1 second.
Delay, that's why we had substituted wherever the t will be there in this equation. You need to substitute. If the time constant delay was 2 seconds, so t minus 2. Okay.
Yes, sir.
See, now you will understand in a better way by solving this particular question. This is a special cases. If this question is clear, then it's fine. See, the question now, the different question is what? In the below given electrical network, at t is equals to 0, the switch in the below given electrical network at t is equals to 0 second, the switch 1 is connected at position 1, is closed at position 1 is closed, and after 4 and 4 second later, 4 second later the switch 2 is closed. Now you need to find the current expression. So current expression for t greater than 0. So same concept will be applicable. Current expression for t greater than 0. Okay, so see, the circuit is, this is your circuit, this is S1, this particular is your S2, this is 2 ohm, this particular is positive, negative, and this is your inductor I, 5 Henry, and here it is connected a 6 ohm. So this is 40 volt and this particular is 4 ohm. Okay, what I want to say you, in the below given electrical network at t is equals to 0, so see this kind of a point first, t is equals to 0. Okay, the switch S1 is connected, means switch S1, we are connecting the switch S1 at t is equals to 0 at position 1. This is your position 1 only. Position 1 is closed. Okay, position 1 is closed. So my position 1, this position 1 is closed. S1 is connected at position 1 is closed, and 4 seconds later switch S2 is closed, and 4 seconds later what we are doing, switch S2 we are doing the closing. So we need to find the current equation. So we what we do, we'll solve the first circuit, will not consider about this particular thing. Okay, so before t is equals to 0, how was my circuit look like? How was my circuit look like before t is equals to 0? How will the circuit look like?
40 volts, 4, 6, 5. Okay.
Okay, see, before means we are doing this connection at t is equals to 0 now. We are not considering about this particular term. So let me highlight this point. We are not considering this particular term right now. We don't know about anything about this. We are just assuming we don't know anything about this. So I am just finding the value of I of t. So before t is equals to 0, suppose your graph is like this. This is your graph from minus infinite to 0 to infinite, and this is here somewhat 4 second. So minus infinite to 0, my circuit was open. So it was a circuit kind of like this circuit, it was open. So 40 volt. So how much current ampere will flow in this particular inductor? I of 0 minus is equals to I of 0 plus is equals to 0. I of 0 is equals to 0 ampere. Okay, so there is a no current up to, this is my 0 minus, this is my 0 plus. So up to 0 plus we are not getting any current, means it's very little bit, we cannot see. So now at t is equals to 0, we are doing, we are connecting this supply. So this is my 4, this is my 6, this is my 5 Henry. So I am assuming the circuit like this. I don't know about this kind of things. At infinite amount of time, what will happen? This will get shorted. And if this will get shorted, what current I will get? I of infinite current, what I will get? 40 divided by 10. I will get 4 ampere. So I am assuming that 0 from 0 plus the current will start increasing, it will start charging, and the saturation point will come at I of infinite, when it will become 4 ampere. So I am assuming these things only. Okay, I am assuming this particular thing only. So it's becoming 4 ampere at I of infinite. Now you need means but what in the questions what they had written, after 4 second your switch S2 is getting closed, right? Switch S2 is getting closed, but you need to find the value of for 4 second current. So you know this this circuit now. So put the value I of t is equals to I of infinite minus I of infinite minus I of 0 e power minus RT by L. So what you will get? I of infinite is 4. I of infinity is 4. E power minus R value, how much R value will get? 10. From seeing this, it will get short circuited, so directly I am telling it will be 10. So minus 10 T and L value is 5. So we are getting 4, 1 minus E2T, minus will be there. So we are getting 4 into 1 minus e power minus 2t. This is my I of t current. So this is the equation of this particular curve, 4 into 1 minus e power minus 2t. But this is the equation for ideal equation for this. But at t is equals to 4 na, at t is equals to 4 na, this will not follow. This thing will not follow because we are operating one switching operation. It's getting closed. But at t is equals to 4 minus and 4 plus we'll get some current. So first we'll find the value of I of 4 minus or I of 4 plus. Substitute the value and get the result. 4 into 1 minus e power minus 2 into 4. So what current you will get? 4 into 1 minus e power minus 8. What value you will get? 3.99, I think. 3.99. That is approximately equal to 4 only. So I of 4 minus we are getting as a 3.99 and I of 4 plus we are getting this. So this is becoming for the second switching 0 minus and 0 plus. Okay, now after t greater than 4 second, my switch circuit will become like what? It will connect it to S1 also, it will connect it to S2 also. It will connect it to S1 also and it will connect it to S2 also. This is 4 ohm. This particular is 2 ohm. This particular is your 6 ohm. And this particular is your 5 Henry. Because they said that they will close the switch S2 at t is equals to 4 second, and they didn't say about S1. S1 will remain closed. So now you need to find the value of I of infinite for this current. So this will become short circuited. Assume V here and get the value. V minus 40 by 4 plus this is your 10 value. So V minus 10 by 2 plus V by 6 is equals to 0. So V 1 by 4 plus 1 by 2 plus 1 by 6 is equals to 10 plus 5, 10 plus 5, 15. Solve this equation and get the result. 4 inverse plus 2 inverse plus 6 inverse. Okay, we are getting 11 by 12, so 12 into 8. So 15 into 12 divided by 11. So 16 point V value you will get 16.366. So we are getting 16.366. So what will be the I of infinite current? So 16.366 divided by 6. So 2.727 I of infinite you will get 2.727 ampere. Yeah, 2.727 ampere. Now substitute the value. Yeah, and one thing you need to find the value of R. R from watching from this particular view. So this will become short circuit, this will become short circuit. So how this circuit will look like? This particular is your 4 ohm, this particular is your 2 ohm, this particular is your 6 ohm, this is your short circuit. So you are watching from this. So 4 into 2, 4 into 2 divided by 6 plus 6. So 2 by 3. So you are getting R value is 18 plus 4, 22 by 3. So this is your R equivalent value. Okay. Now substitute the equations for I of t is equals to I of infinite. I of infinite we got 2.727 minus I of infinite we got 2.727 minus I of 0, but will not consider 0, will consider I of 4 minus, and I of 4 minus is 3.99 because we are seeing after the 4 second. So 3.99 and e power minus t minus 4 because 4 second delay into RT by L. So R we got 22 by 3, 22 by 3, RT by L, L is 500, L is 500. So I of t we are getting 2.727 minus 2.727 minus 3.99. So that will be minus will become 1.263 e power minus t minus 4, and 22 by 15. 22 by 15 value is 22 divided by 15 value is so 1.466. So you are getting the equation 2.727 plus 1.263 e power minus 1.466 into 1 into t minus 4. This is your I of t value. For t greater than 0, for t greater than 4, for t greater than 4. Priyanka, you understood what I did it?
Yes, sir.
Is this clear? Means the concept is clear. Okay. So this kind of a things is for special cases. So same concept you have to use. Question is same question only. At t is equals to 0, the switch is connected at position 1, and after one time constant it is move to position 2. You need to find the current response. Current response when the switch is connected to position 2. When the switch is connected to position 2. Switch is connected to position 2. So see, the circuit is this simple circuit: negative positive, positive negative, 100 volt, this is 50 volt, this is 1, position 1, this particular is your position 2 switch. So this is your capacitor. So in this case we need to find the value of, first we need to find the value of a plus minus Vc. Okay, 1 ohm. So guys, before the operation at t is equals to 0 to 1 second, how was my circuit? It was simply looking like plus minus 100. We are not considering this second part. First it was open, it is like this, plus minus Vc 1 ohm. So Vc value, because it is not interconnected, we are not connecting this, it's not getting any source from any voltage, so Vc 0 minus is equals to Vc 0 plus is equals to 0 voltage. Okay, when I will connect this supply at t greater than 0, then I will get Vc value, and you know na, in a capacitor what will happen, it will become open circuit after some time. So it will get open circuit, this particular terms will get open circuit, plus minus Vc. So plus minus Vc value, and open circuit means current is 0, so Vc of infinite value is how much, 100. And from seeing from here means you are a circuit like this, and from capacitor point of view it is short circuited, this is 1 ohm. Seeing from here, what R equivalent you are getting, 1 ohm. Now put the value and get the value of a Vc of t. Vc of t is equals to Vc infinite, 100 minus 100, Vc 0 e power minus t by Rc, because 100 minus 100 e power minus t by Rc. So R value is 1 only and C value is 1 only, so it will be t only. So 100 1 minus e power minus t. Okay, so this is the story for Vc of t for the first circuit. But guys, means actually the thing is, we have a graph like this. My inductor, my capacitor voltage was 0 from minus infinite to 0 position. It was 0. So at 0 plus it's getting charging, because we are connecting at position 0, we are connecting at this. Now I am assuming this will get charged till infinite. At infinite it will be 100 only. But in between this only na, transient is happening. We are again switching at after what second? After 1 second. So after 1 second I am again switching, and I have to get this value. Okay, so put the value of Vc1 is equals to 100 minus 100 e power minus 1. So you will get 100 into 1 minus shift 63.21 only. So we are getting 63.21 voltage at what position? Vc of 1. So Vc of 1 means at this particular, I am assuming somewhere far, little bit far. at 1 second 63.21. Okay, now we'll moved to second circuit. So second circuit is what's happening. Second circuit what's happening, its supply is connected to second position. If the supply will be connected to the second position like this, positive negative, and there is 1 ohm resistor and positive negative, this is plus minus Vc, and this is 50 volt. So Vc value at infinite you will get how much? At infinite it will become open circuit, so no current will flow, so Vc of infinite you will get 50. So you are getting a new equation of a Vc of t is equals to 50 minus Vc of infinite minus Vc of infinite is 50 minus Vc of 1 second. 1 second, because capacitor will not allow the sudden change of voltage. At 1 second the voltage for that capacitor was 63.21, so we have to write 63.21 only, and e power minus t by rc, e power minus t by rc. R equivalent will be how much? Now your final circuit is look like this, so you have to one only. So 1 into C is 1. So you are getting we are having a delay of how much? 1 second. So t minus 1 will be there. Okay, delay of 1 second. So t minus 1. So Vc of t will be 50 minus 63.21, it's 13.21, so plus 13.21 e power minus t minus 1. So now this value will not go up to 100, it will go like this, and it will this up to 50 only, it will get settled out. But in the question what they had asked now, they had asked we got the value across the capacitor, but they had asked IC of t. So no problem, I is equals to C dV by dt. So C value was 1, differentiate this, you will get 13.T1 minus e power minus t minus 1 only. If you will differentiate this will become 0, 13.21. So minus will come, minus 13.21 e power minus t minus 1. So this is the current what you will get. IC of 1. And C value was, capacitor value was 1 farad only, no? Yeah.
Yes, sir.
So you understood how to solve this kind of a special cases,
Yes, sir. Now,
or still having any problem in this?
daily essence.
Okay, it's clear then. Fine. Now we have a model 2. So this was the story of the special cases. Now what will happen when you will have both inductor and capacitor together? If you will get both inductor and capacitor together, then how you will solve the circuit? Like suppose you have a questions. So t is equals to 0, you are switching on the circuit. This is your capacitor, this is your inductor, this particular positive negative V, and this is R value, this is L value, this is your C value, this is your R1 value, R1 value. Now see, you have a capacitor also and inductor also. So guys, how you will solve this circuit? And at t is equals to 0, your switch is getting, at t is equals to 0 means here in this question you need to find the voltage across the switch, means voltage across the switch, plus minus Vs, voltage across this switch at t is equals to 0 plus. So how you will solve this circuit? So before the at t is equal to 0, what they are doing, they are opening the switch. So before this, how was my circuit? It was closed like this, it was closed like this. Okay, this was closed like this. We know that Vc 0 plus is equals to Vc 0 minus. So, and this is the case from minus infinite to 0. So in a capacitor, what's happening? Capacitor is getting open circuit, right? Capacitor is getting open circuit. So capacitor is getting open circuit, so I am just making it as an open circuit. So there will be a no current, so it's nothing. And what about the inductor? Inductor is getting short circuited, so the circuit will be this only. So guys, what current will flow in this particular circuit? So this V divided by R only. I will be V by R, because this is nothing, this is a hanging wire, it's becoming 0 and it's short circuit, and you need to find the value of a Vc, plus minus Vc. So and here the current is 0, this is your R1. So what will the value of a Vc? Vc value will be minus V plus Vc plus Vc minus Vc plus Vc minus C minus V plus 0 into R1 plus Vc1 plus V by R into R is equals to 0. So this value we are getting cancelled out. So Vc value you are getting 0. So you have inductor current I of 0 minus is equals to I of 0 plus is equals to I of 0 is equals to V by R. Okay, and you have a Vc 0 minus is equals to Vc 0 plus is equals to Vc of 0 is equals to 0. And when the switch is getting open like this, It's getting open. The switch is getting open like this. So I am just taking the switch. My switch is getting open. So I am taking plus minus some voltage drop between this. So I am just taking like this random. And I have R1 because they had asked the switch voltage at 0 t is equals to 0 plus, and we know that at t is equals to 0 plus the capacitor voltage is same, and we are getting that voltage is 0. So that's why I am not making anything. I am just making it as a 0. And this is my positive negative V, and at 0 there will be a inductor current was coming how much? V by R. So inductor current and this particular is your R, and in this branch at 0 at t is equals to 0 plus, all remember this point very carefully. We are talking about at t is equals to 0 plus, not infinite position. So at t is equals to 0 plus, my current is moving as a I is equals to V by R. V by R. This is R value. Now what will be the inductor value at t is equals to 0 plus? V is equals to L di by dt. So you will get, because di value is how much? Di value at t is equals to 0 plus, di value is V by R, and V by R is the constant value, so it will be shorted only. So this will be shorted only. You need to find the value of plus minus Vs. Apply the KVL. Minus V plus Vs plus V by R into R is equals to 0. So V of S will be 0. Suppose this is your R2 value. And V by and yeah, so I'm getting a current, this particular current, that my I of current is this value I am assuming as a R2. So I am getting V by R2. Okay. And if I am applying this minus V 0 R1, so that's why minus V plus Vc, that is 0, plus V by R2 into R2, so Vc value was 0 only. IC 0 minus is equals to IC 0 plus is equals to IC 0. This is V by R2 only. Okay. So we need to find the voltage across this particular this. And this is my V by R2 value. Okay, V by R2 value. So you can, so voltage across this particular, suppose the current is moving like this now. So if you got the voltage across this, so you will got the voltage across V of S. This is, so if you will get the voltage across it, so apply the voltage divider rule. So V into R1 divided by R1 plus R2. So V of S at 0 plus will be V into R1 divided by R1 plus R2. Okay, or you can do one thing, you can also make it like this. This is also correct, and this particular current is moving, so voltage across this R1 will be how much? V into R1 by R2. Okay, both are same, so both could be the answer. Priyanka, understood?
Yes, sir.
We need to find the
Yeah, clear.
voltage across the switch. So what I did now, I hope you got this. Means like see, at t is equals to 0 plus, what is happening? At t is equals to 0 plus my capacitor, I'm assuming from a time minus infinite to 0, so my capacitor was open circuited and my inductor was short circuited. If it is open circuited, if it is short circuited, so what current will flow? V divided by R2. V divided by R2. Okay, and what will be the Vc0 minus? This is your 0 ampere current, so Vc0 minus will be apply the KVL in this particular loop, anywhere. So minus V plus 0 into R1, that is Vc, plus Vc plus V by R2 into R2, you will get the Vc value is 0. That is Vc 0 plus value, Vc 0 minus value, it is 0. Now you need to find the, when this switch is getting open now, you need to find the voltage across that switch. Okay, so okay, no problem. Now at t is equals to 0, also my Vc0 will remain shorted, because we know that Vc0 minus is equals to Vc0 plus is equals to Vc0, and my inductor current will remain that only, V by R2, and the voltage will be shorted. So if you have this voltage, if you have this current V by R2, and if you multiply it with this resistor V by R2 into R1, so this is my, this I am getting positive negative V divided by V into R1 divided by R2. So this is my voltage is coming, particular this positive to negative, and this is parallel to plus minus switch voltage. So my switch voltage will be this. And also I, with the help of voltage divider rule, we can do V into R1 divided by R1 plus R2. So both option in means one option is like this, V of switch will be V into R1 divided by R2, and they can give you the option like this also, V into R1 divided by R1 plus R2. So this is the story of this particular question, that is model 2, and there is a 2-3 questions like that. 2-3 questions is like that, and then we'll move, means tomorrow we'll move for a series RLC network, and that we'll see about the damping factor, what is zeta, what is omega n, what is natural frequency, critical damped, over damped. So it's related to control system, so it's very important. The topic is over damped, critical damped, under damped. This topic is very important, don't miss it. And after finishing this, we'll move to the AC transient. Tomorrow itself we'll move to the AC transient.
Sir, next topic is a control system or AC transient?
See, the topic is related to transient only, and that is your under damped, over damped system na. So
Yeah.
in RLC network na, you have to study under damped, over damped, undamped system. It will come in control system also. Okay, if you'll understood the art.
Yeah, that is in control system.
Yeah, it is the part of the control system, but you have to study in a network also, some part. Okay, so that's why means in a transient it's we have to study that part. Okay, RLC, in series RLC, in parallel RLC. So time constant and damping factors and all you need to study. So it's not very much tough. Like this concept, this questions seems to be a tough, but if you will practice this question, it's a very easy question. It's a bonus question, and you can get a number very easily in this kind of a question. Okay, and yeah, so like we had completed, we just had reached up to 320, 315 pages, like 315 pages within this. I think I had taken a classes for, like I took classes for more than 25, I think, I guess, more than 25 26 classes, I guess. So yeah, 50 hours classes. So I completed 50 hours, I think. And and these topics uh, and for the next few 5 6 days, the whole network will be completed. Then you will be feel very good regarding your network. Whenever you will able to solve all the problems of the gate and all, you will feel very good. So it's a very slow process. Give your time, take your time, prepare the next subject, revise the previous subject. So you will do it continuously with a consistent, in a very good way, then the result will definitely come. Okay, so bye, we'll meet tomorrow. And please revise this topic. Okay, Priyanka, please revise this topic.